All right, so we're going to look at permutations and combinations. So as you can read here, a permutation occurs when a group of objects or people are arranged in a certain order. All right, so here the key thing to know is that order matters. Kind of key thing to think about when you're looking at permutations is the fact that you're looking at ranking or arranging something as you do a permutation. So the formula is NPR, where N stands for the number of objects and R stands for the selection size. And so if I have 15 things and I want to arrange 8 of them, then that would be 15P8. Kind of give you an idea of some things that are permutations would be if you're trying to figure out winners in a race, like positions 1, 2, and 3 in the race, or you're filling certain positions like on a council, like president, vice president, secretary, treasurer, those things. Those are all permutations because the order in which the people are selected or the objects are selected matters. Easiest thing here is if we're trying to do this in the calculator, let's say we have 9P3, all right? I've got 9 objects and I want to put 3 of them in order. So if I'm going to do that, then in the calculator I'm going to type in 9, then I'm going to go to math, I'm going to arrow over to PRB, and I'm going to select, let me show you. And if you'll look here, you can see I want to select number 2. Number 2 is the one that says NPR. So you type in the 9, you go to math, arrow over to PRB, select number 2 that says NPR, and then you would type in the 3, and then you would hit enter. And so that would tell you how many ways you can have 9 objects and you can arrange 3 of them in a specific order. All right, if we look at what's the difference with a combination. So it says combination is an arrangement or selection of objects in which order is not important. All right, so there, that's the key part there. Order is not important when you're looking at a combination. So kind of some examples here is what if you were selecting members for a basketball team, or you were ordering a pizza or something like that. Say you ordered a pizza that was pepperoni and sausage. It doesn't matter in what order you ordered those 2 things, you would still get that pizza that had pepperoni and sausage on it. So similar to permutations, formula here is NCR, and N is still the number of objects, and R is still the selection size. And so if we did an example here with combinations, we could have 7C2. And so you'd have 7 objects and you want to select a group of 2. So we would go in our calculator, type in the 7, go to math, arrow over to PRB, and this time when we go in, you will see that we want to select number 3. Number 3 says NCR. That stands for the combination one. And then we type in our 2, and that would tell us how many ways we could have 7 objects and we could select a group of 2 of those objects. All right, we're going to look at a couple of examples here. So how many ways can you arrange the letters of the word factor? So the word factor, if I count out, has 1, 2, 3, 4, 5, 6 letters. And since I'm arranging them, if I'm arranging them, that's putting them in a order. So here order matters, so that makes this a permutation. So I have 6 letters to arrange or choose from, and we're going to put them in 6 different places, so 6p6. So if I go in my calculator, 6 math PRB number 2, type in a 6, I can see there's 720 ways that I can arrange those 6 letters. Right? How many ways can you choose 2 jelly beans from a bag of 15? Since we're just choosing 2 jelly beans, and it doesn't matter what order they are selected in, this makes this a combination. Right, so we would have 15 jelly beans, and we're going to choose 2 of them. All right, we go back in, 15, over to math, PRB, this time number 3, and we're going to select 2, and there are 105 ways that we can do that. Let's see here. Let's look at a few more examples together. If we go down here to number 8, 7 children are to be lined up in a straight line for a photograph. How many different ways are possible? So this again is lining them up. So lining them up is like arranging them. So this makes this a permutation. So there are 7 children. We're going to put them in 7 spaces. So 7p7. Go in our calculator, type that in, type the 7, then go to math, PRB, and I get that this is 5,040 ways that we can do that. Okay, if we're looking at Sally must be in the middle, so Sally already has a position, so she's not being arranged. So this time, instead of 7, we're going to have 6 to place. 6p6. And if I remember correctly from the previous one we did like that, that was 720. Letter C, how many ways are possible? If we've got, this child has to be on the far left. Same thing as with Sally. He already has a position, so we're not going to put him in a position, so it's still 6p6, and that's going to be 720. And the last part here, how many different ways are possible if Hannah and Brian must be together? So this time you've got 2 people that have to be next to one another. So you got 2 people that have to be in 2 positions. But then you've got 5 other positions that need to be filled. So that's 2p2 times 5p5. So let's see, let's go in our calculator and see what we get this time. And I got 240. Okay, kind of moving along some more. If we look at these questions here, looking at a deck of cards, hopefully you're familiar with the deck of cards. If you're not, then I hope you get that way. So hopefully you know at least that there are 52 cards in a deck. If this first one here says we are going to deal out is to arrange, so this makes it a permutation. If we look down here at number 12, since we're kind of talking about the same problem, this one says how many different hands exist. A hand is like a group, and if it's a group, then that is like a combination. Order does not matter here. So these are going to be basically the same questions. It's just a matter of are we doing C or P when we set it up? So we want to get 5 cards. So there are 52 to choose from. P5. All right, now I'll let you type that in and figure out that answer there. Part B, 52, P10. Some of these may give you scientific notation as the way to write them because they've gotten so large. So that's all right. All right, so you'll be able to do that. Then this one's talking specifically about red cards. Well, if you're familiar with the deck of cards, there are 26 red cards in a deck, and we want to pick 5. And the last one here is we want 4 queens. So there are 4 queens in a deck, so 4, P4. We want to select all 4 of them. So the only difference here is now when we look at number 12, these are combinations, these are groups. So instead of doing P, this time for all of these, we're going to have C. 52, C5. 52, C10. 50, let's see, no, this one wasn't 52 because we're talking about red cards. So this is going to be 26, C5. And the last one, 4C4. So hopefully you should be able to put those in the calculator, and this kind of gives you an idea on the difference between a permutation and a combination. Key thing is, does order matter? If order matters, all right, then you are doing a permutation. If order does not matter, then you're doing a combination. So if you're trying to rank things, put them in an order, all right, arrange them, that's a permutation. If you're selecting a group of something, like a team or just a committee, and it does, all the committee places have the same roles, then that would be a combination. So keep working on these, and I'll be there on Monday to answer some questions if you have any.